Hi everyone. Since I can't be with you in class today, I figured I would make a quick screencast to show you what you should be doing in Excel in order to make your scatter diagrams for this unit. Very, very simple process. We've done this before when we did time series graphs, because to do the time series we need to make a scatter plot. So this will look familiar in terms of what we do. It is, like I said, it's an easy process, but what we really want to be able to do is interpret the information that we're finding out. We're not calculating the equation by hand. We're not going to calculate R squared by hand, which we'll talk about later. And we're not going to calculate R by hand, which is your coefficient correlation. So we're not going to do that by hand. We're going to let Excel do pretty much all the work for us. What I'm looking at here is a sample that I found online. There was a whole lot of other data here, and I pared it down to horsepower in an automobile, the power it has, versus the price. And what I did was I cut out about 250 cars from this list, and I looked at just regular. I'm going to assume regular is a sedan type car, 4 doors, a dad mobile like I have. Non-SUVs or trucks or anything like that. In fact, I cut those out. But this is looking back at a set of data from 2004, which for intents and purposes, what I'm doing for you, it doesn't really matter. It could be 2015 or 2004, and it's still going to give us information that we want. So in terms of what I might be looking at here, I might be looking and asking myself, does the horsepower, the amount of horsepower, have an effect, or does it determine the retail price on a car? Okay, some people might say yes, some people might say no, and some might, frankly, we just don't know. I don't know what the factors are in terms of the prices of cars. So, I found this data. I can quickly create a scatter plot of it and get an idea of, is there a relationship? So all I'm going to do is I'm going to click the 2 columns I want. I'm going to click and highlight them. I'm going to come up to Insert. I'm going to choose my scatter plot. I'm going to choose the one with just the dots. If I choose the one with the lines, it looks like my son or my daughter scribbled on it or connected all the dots. And there we go. Now, once we have our scatter plot, and this is the easy part, and to be honest, there's not really a hard part here. But if you notice, my explanatory variable is the horsepower. Okay, we want horsepower, or we're going to ask ourselves, does horsepower explain the cost? Okay, well, again, we know what we're looking at, or I know what I'm looking at, but does everybody know what they're looking at? So again, what I'm going to do is I want to be able to label my axes. I want to give it a title, which again, I typically title these pretty much the same. It would be horsepower versus cost, or you could say retail price. Let's make it retail price. 2004 sedan. And again, I dressed that pig up pretty nice for the date. It doesn't. If you had horsepower versus retail price, that would be perfectly fine. Now from here, the rest of this, we said we're not going to calculate anything by hand. So the rest of this is just knowing where to go and knowing a couple steps to get the information that we want. So what you're going to do is, you notice up here, Chart Tools is highlighted for you. Okay, we have our chart already highlighted. All we need to do is go to Design. Now, all the coloring and all the little different things that we can do here, a lot of you guys like to mess with the colors and stuff. That's completely up to you. I don't. But that, again, you can change the colors, do what you want, have fun with it. But the most important thing is that we go to Quick Layout. And when you go to Quick Layout on the left side here, I'm going to look for the layout that has the f of x in it. Does everybody see the f of x? Of course you do, yeah. So what I'm going to do is select this one. Oops. And if you notice, it gives me the equation. Gives me an equation. And it gives me a y, that involves my slope, or my rate of change, which in this case would be $211.25 for every 1 horsepower. Okay. And then we have our y-intercept. And it also gives us r squared, which is what we call the coefficient of determination. We'll talk more about that in the next coming day or two. But we said we wanted to find r, not r squared, we want r. And how do we do that? Well, we can let Excel do this for us as well. Why do anything by hand, right? So what I'm going to do is come down here. Now, if you think about it, if I know what r squared is, and I wanted to get back to r, what would you do? Of course, yeah, square root, duh. Yeah, of course we do the square root. So I'm going to click equal square root. I want Excel to do the square root. I was going to type in 0.743. And you get a value of 0.86. Now, what I'm going to do is to display this, click back up here in my text box. I'm just going to enter r is equal to, now I'm not going to enter all of that, 0.862. Since r squared is to the thousandths place, I'll make the r to the thousandths place. The last little thing here is getting rid of this, just to stretch my graph out a little bit. Now we can play with the titles all we want. You know, we can come in and change, or the axes, we can change the units, you know, in terms of how we want it to space it. We can stretch this out a little bit. I don't find it necessary. But as we start looking through this, you know, most of our dots, or most of the data falls really close to the line. Okay. If we think about the residuals, we don't have a whole lot of residuals here. We have a few that seem to be kind of far off, but I'm going to guess like these ones that fall way up here. You know, this is almost a $100,000 car for 300 horsepower. Well, there are other near 300 horsepower cars here that are a lot less expensive. I'm going to bet these are more your high-end luxury cars, maybe Mercedes or Lexus, something like that. And again, feel free to look through the information to find it. But you know, maybe we have one up here. I'm going to bet this is one car that is almost basically a four-door sports car in 2004, and I don't know which one that is. But this is pretty much it. The rest of this, again, we can label our axes, horsepower, if I can spell horsepower. Oh, whoops, I'm sorry. No, I'm sorry. That was retail price. Retail price. And we have horsepower. And, you know, ultimately, here's our equation. We'll do some predicting with this. We'll do some interpolation, which is inside the data we have. We'll also do some extrapolation. You know, what if we have a car with 800 horsepower? You know, what can we predict the price to be? Well, what would you do with the 800? Well, that's your X value. You plug it in and solve for Y. Well, 800 horsepower, we can't even see on the chart. I'm going to bet that's out here somewhere. Okay. The only other thing we're concerned with is what R is. And if we have an R of above 0.8, we could say that's a very strong correlation. So again, if you look at the dots, not a whole lot of residuals here. Small distances to the vertical distances from each point to the line. Okay. And we found we have a pretty strong relationship. Now again, does that mean that the horsepower causes the price to increase? Maybe, maybe not. That's where R squared will come in, and we'll talk more about that later this week. But for now, if you can create your histogram and you can answer what R is and tell that it's weak, strong, not strong, however you want to say it, that's good. That's good enough for now. All right. Thanks. Good luck, and we'll see you tomorrow.